Yes, welcome to the second part of the question, which says expand open brackets 2x minus 3y raised to power 4. Right, so when you are trying to expand that one, all you have to do is to generate the Pascal's triangle. So the Pascal's triangle is generated by saying the first value it's 1, and then on the sides there's 1 1, and then you have on the sides, like I mentioned, it's 1. So it's 1 plus 1, we have a 2 there, and then you have a 1. So we have a 1 on the sides, and then you have 1 plus 2, it's 3. 2 plus 1 is 3 again, and then you have our 1 there. So 1 on the sides, 1 plus 3, you get your 4. 3 plus 3, you get your 6, and then 3 plus 1, you get your 4, and then you have your 1 on the sides as well. Right, so at this point, all you have to do, once you have that triangle there, it becomes way too easy because you already know the coefficients that you're going to use. Right, so now let us move on and then see how we can expand that one. Right, so you see the first value there, it's 1, the coefficient rather, so this is our 1, and then the value it's 2x, of course, power 4, and then negative 3 power 0. Now this, remember to say they reciprocate. The highest value there, it's power 4, so that's what we're going to put on the first value, and then the second value will put a 0, so they will reciprocate. The other one will go up, the other one will go down, so meaning the other power will increase, the other degree power will reduce. That's what we mean. So you will notice as we move on. So this is our 4 as the coefficient, and then we have our 2x raised to power 3. Notice what I mentioned, from 4 it has gone to 3, and then negative 3y it has gone to 1. So meaning this one now increases, which was a 0, it has gone to 1. So the next part is 6, and then we have our 2x raised to power 2. From 3 it has become 2, and then negative 3y it will be raised to power 2. It has increased by a degree of 1, so it has become 2. So the next part is 4, open brackets 2x raised to power 1. From 2 it has become 1, and then negative 3y it has been raised to 3 from 2. Of course, we continue, the rest value is 1, so we have our 2x, now it has become 0, and the friend has become power 4. Now once you are done with that one, it means your work is easy peasy. All you have to do is to just go ahead and find your answer there. So now how do you find your answers there? So you just continue by saying, of course, here when you notice 2x power 4, it means even the 2 is raised to power 4. So 2 to power 4 is 16, and then x power 4, x raised to power 4, it's just x raised to power 4. Any number raised to power 0, it's 1. So this is my 1, this is my 4, and then like I said, it's 3 raised to 2 rather raised to power 3, which is 8, and then x raised to power 3, which is that one. Any number raised to power 1, it's that very number. So we have our negative 3, and then this is plus 6, and then 2x squared is 2x times 2 times x, which is 4x squared, and then negative 3y multiplied by negative 3y, it's going to give us 9y squared, positive of course. And then this is my 4 here. I'm going step by step. So any number raised to power 1 won't change anything, and then negative 3y multiplied by negative 3y multiplied by negative 3y, it's going to give us negative 27y. And then this is 2x power 0, which is just a 1, and then negative 3y raised to power 4, it's going to give us 81y raised to power 4. Now we can continue now and then finish up with our question. So I'm going to multiply 1 times everything here. 1 times 16 times 1, it's just going to give me 16x to power 4. 4 multiplied by 8 times 3, it's 96, and then the x power 3, it's there, and the y, which is a single y, of course, it's that one. So 6 multiplied by 4 times 9, it's 216. Of course, x power 2, y power 2. All right, so we have 2 multiplied by 4 multiplied by 27 is 216 again. Of course, raised to x power 1, and then y power 3. Plus, of course, these are just ones, it won't change anything even if I multiply. So we have our 81y to the power 4. Right, so this is what you do. This is what you do. It's as simple as that. All you need to do is to generate the Pascal's triangle and then have your work underway. Right, so we move on to the next part of the question, which says find the ninth term in the expansion of open brackets 2p plus q raised to power 11. Right, so these are simple questions because you're going to use a combination. Okay, so you have NCR, of course, and the combination of C and R there. Of course, this is the general formula that I've highlighted here when you're trying to find the nth term of a binomial expression. Right, so it's NCR, open brackets A, and then it's N minus R, B raised to power R. So since we're trying to find the ninth term, so meaning our N is the highest value, which is 11, so it's that 11 there. And then, pardon my writing, the R there, it's the nth term minus 1. Nth term minus 1. So 9 minus 1, this is my 8. And then you have our 2p, which is the first value, subtracted by 11 minus 8. Of course, the 8 is the R there. Right, so you just need to punch in your calculator. It's 11. You punch in C, the combination C, and then 8. It's going to give you the coefficient, which is 165. And then 2p raised to power 3, because 11 minus 8 is 3, and then 8, yeah, that. Right, so you have 165 multiplied by, of course, 2p raised to power 3, it's 8p raised to power 3. Right, so in this case, you're just going to multiply 165 multiplied by 8, which is going to give you 1320 p power 3 and 8 power 8. I mean q power 8 rather. Fine, so this is what you do. Yeah, basically that. It's as simple as that. Right, so you move on to the next part of the question. The next part of the question says find the first 4 terms in the expansion of open brackets y minus 2x raised to power 15. So we just need to find the first 4 terms. We use the same idea that we used in our previous question. So you use the combination NCR. So the highest power there is 15. So you put it there for n. And then since we're trying to find the first term, I remember I mentioned earlier on to say it's for any term, the value of r would be term minus 1. So since it's a first term, so term minus 1, it's 0. That's why we've decided to put a 0 there. Okay, put a 0 there, and then the first value it's y. 15, of course it's n minus r, so it's 15 minus 0 there, and then negative 2x raised to power r, the value of r is 0. Yeah, you just punch in your calculator 15 c 0, it's just going to give you 1, and then 15 minus 0, it's 15, so this is just y15 multiplied by any number raised to power 0, it's just 1. Yeah, you just finish up your question. It's 1 multiply everything, because this is just 1, meaning it will not change anything. So your first value it's y raised to power 15. As simple as that. Right, so move on to the next part. What about the second value? The same idea. So it's NCR, the n is 15, the r is 1, knowing to say it's 2 minus 1, isn't it? Right, so you have our y, and then 15 minus 1, which is a 14. Any number raised to power 1 won't change anything, so you have a 15 multiplied by a 2 here. It's going to give you negative 30 y to the power 14, and then a single x there. So basically this is your third, rather your second value. Now remember, I did not start with y. Even if you leave it like that, it's still correct, but it's just me, I usually want to begin with x before y. So whatever the case, multiplication is commutative, so yeah, you can leave it like that or that one. It's up to you. Right, so we move on to the third value, since we're trying to find all the 4 values. So the third value, use the same ideas, the 15 there, and the 2, you know where the 2 is coming from. You subtract 1 from that one, okay, to get your 2. So you punch in your calculator, it's going to give you 105. 15 minus 2, it's going to give you 13. And then negative 2x 2 times, because it's raised to power 2 there. It's 4x squared. And then 105 multiply 4, it's going to give you 420. x power 2 and 13 y raised to power 13. So this would be your third value. Right, so move on to the next part, which is the fourth value. Now, how do you find the fourth value? It's the same idea. 15, 3, because 4 minus 1 there. And then you have y raised to power 15 minus 3, which is a 12. And then negative 2x multiplied by itself 3 times. It's going to give you negative 8x power 3. So it's 455 multiplied by 8, which is 3,640 negative x power 3 y power 12. Right, so basically this would be your fourth value. Now it's, you can leave your answers like that, but it's my own thinking that your answer is supposed to be expressed in a binomial form, meaning you have to combine all of them. Right, so you have y power 15 as the first value, minus 30 xy to the power 14 plus 420 x squared y power 13 minus 3640 x power 3 y power 12. Yeah, it's as simple as that. So meaning you have written down your first 4 terms of that binomial expression. So we move on to the next part of the question, which says find the term independent of x in the expansion 1 over x plus x raised to power 12. Right, so this is quite simple. Right, so all you have to do, it's the same idea, it's under binomial expressions. Right, so all you have to do is to say NCR. You remember the general formula that I mentioned earlier on. A raised to the power n minus r, b raised to power that one. Right, so now in this case, you know to say your n is 12 there. So we'll put our 12. We don't know our r. Then this is 1 over x as our first term here. And then the other term is x, of course, raised to power n minus r, and then to power r there. Well, we move on. So yeah, here, so you know to say this is 12, and then of course, if you followed me through when we are trying to write that one in a standard way, that is in indices, we know to say if we take our x, we take it up, it's going to be a negative power. It's going to hold a negative power, so it's x raised to power negative 1. And then you have our n minus r. Yeah, basically that. So since these are the same, we know to say when we add this and this, we need to get a 0. That's how we're going to find the value of r. So this is my negative 1, which is here, and then open brackets n minus r for the powers. The powers are supposed to add to a 0 so that we get rid of the x value, since we're trying to find the independent value there. So we also have our plus r, which is this one, and then equal to 0. So we have our equation that we're supposed to solve there. Right, so now having written that, we know to say our n is 12. So I'll replace n with 12, and then I'll have negative 1 multiplied by 12. This is my negative 12. Negative and negative will give me positive r, and then I have my positive r equals to 0. Well, so it's r plus r. We have our 2r. The 12 will just go on the other side there, so that we see how we can solve that one. So we have our positive 12 now. Divide both sides by 2 by 2. Our value of r is 6. Right, so we just need to plug in our 6 there and then finish up our answer. It's quite simple. So all you have to do is we plug in our 6 and our 12 there. We'll get 924 when we punch that on a calculator. So we have our 12 minus 6, which is 6 there, and then power 6 there for r, so it's x power 6. So this power 6 is supposed to be equated to both the numerator and the denominator. So notice here I've put my 6 here and I've put my 6 here, meaning these can go. We've gotten rid of the x value. So 1 raised to power 6, it's just 1, and then 1 multiplied by 924, it's just 924, and this is the independent value of x. Right, so this is the second part of the question, and it's done. We look forward to the third part of the question. Please enjoy. Well, welcome to the third part of our video as we look at the third question, which says prove that cosecant theta over cot theta plus tan theta is equal to cosine theta. Right, so for us to prove, we need to make sure that the left hand side is equal to the right hand side. Now, how do we prove that one? So notice I've just picked on the left hand side. I want to make sure that this part here is going to give us that part there. Right, so now let's have things underway. So first things first, I know to say this over would mean divide. The over means you divide. Right, so I know to say cosecant theta, it's the same as 1 over sine theta, and then the division part is that one. So cot theta, it's the same as 1 over tan theta, plus tan theta, it's just tan theta over 1 as a fraction, so that I can deal with fractions which are much more easy to deal with. Right, so now at this point, let me start with what is in the brackets. What is in the brackets is, of course, 1 over tan theta over 1. So lowest common denominator, it's tan there, theta. 1 into tan theta, it's 1 multiplied by 1, which is my 1 there. This is my plus at the middle there. And then I have 1 into tan theta, it's tan theta. Tan theta times tan theta, it's going to give me tan squared theta. There are now 2 tans there. Right, so 1 plus tan theta, tan theta squared, of course, it's secant squared theta. Okay, so the top part here, it's equal to secant. So I've just replaced the top part with secant there. Right, and then over tan theta here. I've not changed anything. Now notice to say, according to the to fractions, division can change into multiplication. So when it changes into multiplication, the numerator becomes the denominator, and the denominator changes into the numerator. Wow. So yeah, cool. So all we are going to do is to we have our 1 over sine theta multiplied by, this one becomes the numerator, tan theta over secant squared theta. We have something like that. Of course, this over, I know it's division, right? So I know it's tan theta divided by secant. It's the same as 1 over cosine. So it's 1 over cosine theta, right? So I have something like that. Okay, we continue there. So I know to say this is my value. I've not changed anything since from the start, so I've just written it like that. And then I have tan theta is the same as, is equal to sine theta over cosine theta, which is here. Okay, that's what tan would mean. Right, so at this point I know to say it's 1 over cosine theta, so it will change into a multiplication sign, meaning this one will go up and that one will come down. So it's the numerator becomes the denominator and the denominator becomes the numerator. Right, so at this point it's cosine theta on top over 1. Now notice now I can cancel, I can simplify it. So this can cancel with that one. Cosine can also enter into the 2 cosines, meaning I'll remain with 1 cosine, isn't it? Because I had 2 cosines for the square there. Right, so meaning I'll have on top I'll have 1 cosine, because 1 has been cancelled with this one, which is at the bottom. So at this point I will have my final answer. I've proved to say cosine theta is equal to cosine theta, hence proved. Quite simple, huh? Right, so let's move on to the next part. To the next part of the question. The next part of the question says solve the equation 3 cosine squared theta plus 5 cosine theta minus 2 is equal to 0. Now notice this looks like a quadratic equation on its own because of the square, the degree of the square. Right, so now for me the simplest way is to let the cosine theta be equal to x. So wherever there is cosine theta, I'll just put x. So I've replaced everywhere where there is cosine theta, I've just put x there. Okay, so this has become something that is so familiar because this now looks like a quadratic equation, which is easy to solve. So at this point, I need to find the product, which is -6, because it's 3 multiplied by 2, which is -6, and the sum is the value that is at the middle there, which is positive 5. So the two values such that when I multiply them, I need to get negative 6. When I add them, I need to get positive 5. It's just 6 and negative 1, because 6 times negative 1 is going to give me negative 6. And then 6 plus negative 1, it's going to give me positive 5. Right, so at this point now I just need to replace. This is my positive 6x, and then now a negative 1 there. Of course it's 1x, so I just had to write x. At this point I just need to factor out what is common in the first brackets there. It's 3x. Here I'll remain with x, because 3x into 2x it's x. 3x into 6x it's 2. Then the negative is outside. What is common here? It's a 1. 1 into negative x, it's just positive x. Negative 1 into negative 2, it's positive 2. Now notice these two values are supposed to be the same to make sure that we are heading the right direction. So at this point, I know to say I'll get what is outside. So we have a positive 3 and negative 1, which is here. And then one of the brackets, I'll just get one of the brackets. What is in the brackets? It's 2x, 2 plus x. X plus 2. Okay, so yeah, so I can now equate the two brackets to 0. So I know to say it's this equals 0 or this equals 0 for my answers. So I just continue and then solve it. The 1 will go on the other side there, and then I'll have a 1 positive, and then over 3 over 3. So x is equal to 1/3, and then x plus 2 is equal to, of course this is just going to go on the other side. It will be negative 2. Now recall what we did. We said cosine of x is equal to x, so we need to bring it back. So let's bring back the cosine of x, as cosine of x is equal to 1/3. So we have our answer, our value there. So yeah, so for us to find, we need to find the inverse of cosine of 1/3. The inverse of cosine of 1/3, it's 70.53 degrees positive. Now for cosine of negative 2, you cannot find that one, so you just need to indicate no solution. That one cannot be calculated. You cannot have a negative 2, it's too big. Right, sure. So we move on. This one, it's done. But for the cosine, which is 70.53, remember that is in the first quadrant. In the first quadrant, cosine is positive. Where else is cosine positive? Because we have found 70.53 here. Where else is it positive? Of course it's in the fourth quadrant. It's in the fourth quadrant. So if it's in the fourth quadrant, it's 360 minus 70.53, which is going to give us 289.47, meaning we are done and dusted with that question. Right, so that was question number 3. We now look forward to question number 4. Please enjoy.